Welcome to the deep dive. Today we're cutting through the noise on something pretty extraordinary. The models are predicting what's being called the Great Eurasian Weather Divergence for mid to late January 2026. Our mission is to dig into why, exactly, Europe is about to split into two, well, violently opposite weather regimes at the same time.
It's a fascinating setup, and it's a top-down problem, The root cause is something called a major sudden stratospheric warming, an SSW.
An SSW. Okay, so break that down.
Think of it as a catastrophic collapse of the polar vortex, but way up high. We're talking a total reversal of the winds at 30 kilometers altitude.
30 kilometers. So this is a problem that starts way above us, and then it sort of trickles down.
Exactly. It doesn't hit us right away. There's this downward linkage, a delay of about 2 to 3 weeks before that chaos up there triggers the extreme weather we're about to see at the surface.
That brings up a question that I think a lot of people have. We're always hearing about a warming climate, so how are these cold snaps getting more violent, not less? It seems a bit counterintuitive.
It does, but it connects directly to the bigger climate dynamics. Arctic amplification has weakened the jet stream.
So it's not a straight, fast river of air anymore.
No, not at all. It's become wavy, what we call meridional. And when those big, lazy loops get stuck, you get a massive atmospheric traffic jam. A Rex block.
A parking lot for weather systems.
A perfect description. And here's the kicker. The atmosphere now holds 7% more moisture for every degree of warming. So when a cold snap does punch through that block, it's loaded with much more moisture, much more violent.
Okay, so let's get to the split itself. Western Europe seems to be getting a real break.
A huge reprieve. They were just battered by Storm Goretti with gusts up to 160 kilometers per hour.
And now?
Now a massive Scandinavian high is building, a huge stabilizing force. Temperatures across the UK and France are forecast to be 2 to 4 degrees Celsius above normal.
Which means relief for the infrastructure, right?
Huge relief. The sources are projecting a 15% drop in heating demand there. But contrast that with Central and Eastern Europe.
Still in the freezer.
Deep in the freezer. They're stuck in that Arctic cold pool. We're looking at temperatures 10 to 15 degrees Celsius below normal. This is a genuinely dangerous cold.
So what does that look like on the ground? What are the specific hazards?
Well, look at Moscow. They're facing what the reports call scorching frosts.
Scorching frost?
Down to minus 20 Celsius at night. And remember, that's on top of the record 65-centimeter snow drifts they got from Cyclone Francis. That's waist-high snow.
Wow. It's not just Moscow.
No. Belarus, the Northern Balkans, they're facing red-level warnings for heavy snow. Blizzards could dump another 60 centimeters in some places.
Let's shift from, personal safety to commerce. The sources flag a big hit to the Trans-Siberian land bridge.
Yes, this is critical. Russian Railways has to cut train lengths, sometimes from 150 cars down to 80, once it gets below minus 25 Celsius.
And why is that?
It's the pneumatic braking systems. Over those vast distances, the extreme cold makes them less reliable, so for safety, the trains have to be shorter.
So you're looking at a 40% cut in rail capacity, more or less. That's a huge bottleneck for goods heading west.
A massive one. And it's not just finished goods. Think about agriculture. There's a serious risk of winter kill for wheat crops in southwest Russia and Ukraine.
How does that work?
You get a sudden hard freeze down to minus 12, minus 15, hitting bare ground that doesn't have a protective layer of snow. It just kills the dormant crop. Devastating for the next harvest.
And finally, there's the energy situation in Ukraine, which sounds incredibly fragile.
It is. Peak demand during this cold snap could hit 18.5 gigawatts. But with their infrastructure issues, the supply deficit could be as high as 6 gigawatts.
A 6-gigawatt gap. So they're completely dependent on gas imports from the West to keep the lights on.
To keep essential systems running, yes. They're relying on those physical west-to-east gas flows from the EU.
So when you pull it all together, this 2026 divergence really feels like a preview of something new.
I think the sources call it reliable instability, and that's the perfect term. The core message here, for you, for policymakers, is we have to stop planning for 1-in-100-year events.
Because they're not anymore.
They're not. Our infrastructure now has to handle both ice shells and bomb cyclones, sometimes at the same time in different places.
It leaves you with a pretty challenging thought then. Given how often we're seeing these stratospheric disruptions and with atmospheric rivers shifting poleward, how long can we actually rely on historical averages to predict future risk? It seems we have to plan for a predictably unpredictable future.